Hello, I'm Eric Snodgrass, and thank you for watching this weekly ag weather update for the Farm Credit Associations of North Carolina. Thanks for giving me a little extra time here on Monday morning. I wanted to spend some extra time kind of just putting together the primary ideas behind the large volcanic eruption that we saw over here in this part of the Pacific Ocean. Now, to do this, I want to really build a story on what the potential impacts of this eruption could be to get our video started today. So I'm going to show you an animation here, and you're going to watch right here. See that event right there. Now, just so you get oriented, we're very close to Fiji, and over here is the east coast of Australia, and that is New Zealand. So we're in the southern hemisphere, and the island over which this massive volcanic eruption occurred. So let me take you back there so you can see it again. Right there, you see the eruption. This was the island of Tonga, and that eruption was impressive to say the least. Now you can start to see the shock wave that came out. See the ring right in through here? I'll kind of highlight that and then play it for you. Watch this animation again. Ready? Eruption, massive shock wave. And as that shock wave went out, we not only captured that on visible satellite imagery, but also on infrared. So again, your attention is going to be right in this area. As we play this forward, you'll see the eruption. There it is. And you can see the shock wave just spreading across the rest of the world. Now, when we see such massive eruptions like this, questions start to come to mind. And the first question is, what did this particular eruption mean in terms of changing the atmospheric composition, specifically with aerosols? And I want to have a talk about that. So let me get right into kind of what I've got for you presented here. And let's make this full screen so we can see it a bit better. And let's start off talking about the last time we saw a massive eruption. This was back in 1991 in mid-June. This was the eruption of Pinatubo. Now, Mount Pinatubo here, as you see erupting here in the Philippines, was just an incredible eruption. And there are some differences to be explained because a lot of folks are comparing this current volcanic eruption to Pinatubo. And this is where I want to start. Now, when we consider the climate and weather impacts of a volcanic eruption, a lot of that discussion goes around sulfur dioxide, SO2. And we can roughly think of this as being an aerosol, a chemical, a gas that's in the upper levels of the atmosphere that is going to impact the way that sunlight is transmitted through the stratosphere down to the surface. Now, when you look historically, each one of these circles is a different volcanic eruption, and it talks about the volcanic plume altitude, how high it got into the sky. And generally speaking, we see that the stratosphere begins, let's just call it somewhere between 10 and 12 kilometers. So some big ones to talk about here. This dot right here, the big red one in the back, that is Mount St. Helens. But Mount St. Helens did not produce the same type of stratospheric aerosol injection as this one here. I'm sorry if I'm pronouncing this wrong, but El Chichon, this one was in Mexico, and then there's Pinatubo right here. So you can see Pinatubo put a tremendous amount of ash, soot, debris, certain aerosols, and sulfur dioxide into the stratosphere. And since then, we've not had one that's been comparable. Now, I'm going to talk about the current eruption, but let's get the science down behind this, all right? Now, just looking at a paper here that was published out of Rutgers University, and this is just a good example of how this works. When we look at the apparent transmission, that's how much sunlight gets through the atmosphere to the surface, we can see some of these very large volcanic eruptions, like this one here. This is El Chichon, and this one here would be Pinatubo. So these massive drops in the value here of transmission means that we're basically removing a lot of direct sunlight, and we are increasing indirect sunlight as it comes into the lower atmosphere. The other thing that happens with this is that they tend to warm the stratosphere. See, these are big spikes in stratospheric warming when those huge volcanoes, El Chichon and Pinatubo, erupted. Now, this paper was published a few years ago, so you notice we don't have current data from the current system that just erupted, but let's see the effect of these two things on global temperatures next. So what I did here was using a tool from NOAA. It's called Climate at a Glance. It's one of my favorites. I looked at, since 1880, global temperatures. All right. So this is a pretty well-known curve, and you can see here the global temperatures increasing, but we're looking for the near-term effects of these volcanic eruptions. So I'm going to get over here. Let's get right into here. This is 1981 and 82 when we're watching that volcanic eruption, really 1982 for El Chichon. And what you notice is that in the years following, with the exception of 83, okay, we saw temperatures that were not necessarily following this upward trend like that, but were down here. Now, they certainly weren't below the long-term climatological average, but there was a couple of years where we could notice a global cooling effect. And we saw that again right here. This was 1991 when Pinatubo erupted. And if you look at the years following, they were nowhere near as warm as the years before this. So we know that there is a net effect of warming the stratosphere, cooling the troposphere, the layer we live in, and it can be to the tune of a half a degree to a degree kind of globally, and that's in Fahrenheit. Those are degrees Fahrenheit. Now, coming down to just the United States, let's take a look at this again. So we come over here to 1982, and what you notice is that the years following El Chichon, we did not see really hot temperatures across much of the United States. And the same thing, look right here. Let me get back to it. There's 1991. So this is when Pinatubo erupted. And the years following also were not, really, really warm compared to the climatological average. Now, with all of that said, these massive volcanic eruptions, which put a lot of sulfur dioxide into the stratosphere, had this effect. What did it do to certain parts of the country? Well, I can speak a lot about what happened in the Corn Belt. Why don't I just give you an idea here? Because in 1991, while yields in the Corn Belt were off by about 7 bushel below trend, it was actually a very warm and dry summer. Okay, remember the volcano erupted in June. That summer following that was not yet affected, that summer that this occurred in was not yet affected by the volcano, and we saw hot, dry conditions peeling off yield. But then in 1992, okay, the year following where the temperatures came down, better precipitation, yields in the Corn Belt were 10 bushel above trend. Then in 1993, this is where I want to be very clear. There is no peer-reviewed journal that I have been able to find that blames the flooding in 1993 directly on Pinatubo's eruption in 1991. You might be hearing that from people. I'm just telling you, I cannot find peer-reviewed research that supports that idea that Pinatubo is to blame for the floods of 1993. Now, since we're talking so much about this, we got to come back to our current volcanic eruption. And I just want to show you, this is the latest data we have from satellite on how much stratospheric sulfur dioxide has been put into the atmosphere above that volcano. Now, what we would need to be watching for over the coming days and weeks is if that right there expands. And at this point, there is no evidence to support that it will. All right, just none right now to support that it will. So in other words, what I know up to this point is what I just told you. I'll be looking at this every single day we get our high-resolution satellites passing over it. So that's the near-term ideas we've got about this. I am saying that I don't expect any sort of sizable climate disruption that could affect production agriculture, especially in the northern hemisphere, especially in the North America at this point. If that changes, I will let you know, but that's my current assessment of what's going on. Now, I had to go to Twitter to kind of get an idea about this. I'm going to turn the sound off just in case some of these have some sound, just to see what it looked like. And this was a pretty just incredible view of that shockwave. You can see it right here. This is from the Himawari 8 satellite. And then also I wanted to show you this. Now this was some graphs of the pressure perturbations or changes across Australia. And so the closer you were to the eruption, the sooner you saw the pressure change. Now look at this. This is a 7 hectopascal. That's a 7 millibar change in pressure. That is a large enough change in pressure that I imagine people here had their ears pop, and they certainly heard the sound from this particular event. And then why the wave goes like this is because we're getting farther and farther away. For example, Brisbane to Perth. This is on the eastern side in Queensland. This is on the western side in Western Australia. In terms of storm surge, not storm surge, mixing my terms up here. In terms of tsunami effect, we did see some very impressive, waves, successive waves that kind of came in here. This was in California. We saw something like this in Oregon as well. We measured anywhere between a 1/2 foot and 3 feet of tsunami wave depth from this particular event. And then I've got to show you this because I just don't fully understand it. But this was what some people decided to do near the tsunami wave. I don't know why that guy is fighting this tree before it gets here, but he's wearing a life vest. And these people are out trying to get video of this. and this is the tsunami wave coming in. I just do not advise ever doing anything like this. This is not intelligent. So now he holds on to the tree he was trying to knock down. I don't know what happened to these people after this, but you can see this is what you should not do in the event of a tsunami. Sorry, let's go back to that, and let me just escape out of this particular video. There we go. All right, now let's get back to the other thing we saw happen. In fact, let's just blow this up so we can see it a little bit better here. This was the weekend snowfall through 7 a.m. Eastern time this morning. So the system that went, that really interesting system that came out of Alberta here, went right through the part of the plains and Midwest, hooked really hard to the east here, and is running up the East Coast today, put down some pretty heavy snow, especially in the Appalachian Mountains. And we're going to be spreading more snow in the Northeast today. Now, thinking about all of that, I'm going to come back to a discussion we've been having, because later this week, we're going to get a new drought monitor update. And I am excited to see that one, because the one that came out last week still shows drought in our area. And what I want to do is I want to come here to the change maps, and I'd like to show you how much the drought monitor has changed just in the last month. And you can see that we have some places in South Carolina, Central North Carolina that have seen a 1 to 2 class improvement. And this is only going to be getting better with time. And let me show you why I'm saying that. First of all, if you'd like to just see the size of this winter storm, this is this morning since the sun came up. We are now firmly in the dry slot on the back side of this. And this winter storm is just barreling through parts of New England, putting down some pretty heavy snow in those areas. But as we think about where this is going afterward, I have to just show you the upper level pattern, and then you'll see why I think we're going to continue to see drought recovery. All right, there's the deep trough. That's last night, went right over North Carolina to Virginia, and this morning is moving toward the Northeast. Now after that, what we're going to be watching midweek is this trough of low pressure, because that particular one's going to produce a system that goes through the Great Lakes and then dives south, bringing a pretty sharp cold front through us, and we've got the potential for more snow and ice out of that one. Now watch this. Through the weekend and into early next week, what does the atmosphere do? Highly amplified into a big ridge that forms here along the west and a deeper trough anchored between the Great Lakes, New England, and the Hudson Bay. And the models want to keep that around through almost the end of January. So the likelihood of us seeing anything like sustained above average temperatures is very low. In fact, you're going to see quite a bit of cold air here on the eastern side of the United States. That ridge by the end of January, though, moves west. And as it does so, that's going to change things up. Because right as soon as we finish January and start the month of February, I see this happening. The flow is really going back to doing something like this. Now, if we start to see some sort of subtropical ridging forming over parts of Florida, this trough here in the west gives us southwest flow, and things are going to go over very active for us to start February. Not that they haven't been active in January, but boy, this is an interesting pattern to look at. Now, my website is down this morning. I got some maintenance going on there, so I'm using WeatherBell for my maps today. And I want to show you what the latest European runs show. So I produce these maps, but this is just from WeatherBell today. So first system, this is surface precipitation type and intensity. That one is out, okay? So through Tuesday, now getting into Tuesday midday, Tuesday evening, and now into Wednesday morning. Now what you saw after that was we were drier, but this Clipper system moved over here over Lake Huron. It's got a front drape to its south. Now watch this. Please watch this very carefully. As we go through Wednesday afternoon and evening, and now getting into Thursday, early Thursday morning, that front will move over the Appalachian Mountains, and you see this high pressure cell behind it, very, very cold air coming in behind this. Now, as that front moves over us Thursday throughout the day, it is in the overnight hours, Thursday night to Friday morning, that I'm most concerned. And that's because as the front sits here, you know how this works. We get cold air damming that comes right up here, butting up against the Appalachian Mountains along the Piedmont, right in through this area. And what occurs here is you get overrunning, where there's very cold air at the surface and warmer air aloft. And the models through early Friday morning right now are projecting, see the pink? That would be the risk for, that would be our risk for maybe some mixed precipitation, ice or freezing rain. And so ice pellets or freezing rain. And as that comes over here, we're just going to have to be very aware late this week of how this could impact. Right now, the timing is overnight Thursday night to Friday morning, but there's a lot of uncertainty. This is all about the timing of the front, the extent of the colder air that has to get underneath it. But I want to tell you, just be on the lookout for this. And that high pressure cell that follows helps initiate this cyclone to move up the coast. And as it does so, we could see some snow on the backside of this with that colder air. Now we put all that together, we're going to look at this two different ways. This is just through the next week. When you melt all that down, what could potentially be some ice and some sleet, and then the following with snow, you melt it all down. The model's putting down anywhere between 1 inch and 2.5 inches of liquid equivalent just through the next 7 days. So now you see how we expect this drought problem to continue to erode away. And we cannot yet definitively, I mean, it was just like last Monday when I was talking about this system last week. I couldn't definitively tell you anything yet because it was an end of week system. And it's the same story here. But what I can show you is this. This is the probability of getting 1 inch of snow. So that first big red blob there with high probability, that's the big winter storm right now. We're watching later on this week. And where we start to see this, look right there. This is Thursday night to Friday morning. The probabilities are increasing through Friday and into Saturday, where we could have the chance, better than 50% up to 60 and 70% chance of getting more snow or sleet or ice. So I just want you to watch this all week long. Please keep a close eye on this. Now, where are we going after that? Well, as you saw, the jet stream maintains that deeper trough here through day 10, and it backs up. See this backing up here as we finish the month. Now that gives us a precipitation pattern that looks like this to finish the month. The highly amplified flow coming over like that keeps the storm track pretty far to the south. This is biased too dry in this area. It's too dry. There will be more weather systems rolling through this area, increasing the precipitation. Now, just thinking about that, let's stop here with the precip. I'll come back to it in a second for the long range, but I want to talk about temperatures first, because we got some cold air in place here, and this is basically just a 1 day sliding window of temperature anomalies. So there's the cold air that's in place now, and it sticks around through Tuesday and Wednesday. Now we might get this brief warm up going from Wednesday night into Thursday, but look at the cold air that's following it here. That's the cold air that's going to settle in. Can you see the cold air damming that little cold tongue in through there? That's what we're going to be watching out for Friday morning, and then that cold air settles in after that. And from that point forward, take a look. This is day 5 through 10. Look at how much cold air is in place here. Temperatures will be anywhere between 8 to 15 degrees colder than average, and that seems to last. I'll just let this slide forward here all the way through the end of this month. So we've got cold air in place during that time period. Now, since we're talking about temperatures, let's get the longer range discussion going here. Our La Nina, it's still going here, as we've been talking about, but fading in this part of the Pacific. We still got our cold water in the Gulf of Alaska. Now, when we start to see how this is going to impact the MJO, how this is going to impact the typical La Nina type weather patterns across North America, we stitch them together to get this. The MJO, look at this column of blues here and in here. What that tells me is that there's going to be broad scale rising motion out here in phase 6, 7, and 8. And the MJO right now just came out of phase 8 and is weakly in the null space here, but it's going to pop out into phase 6 and probably come back to phase 7 before in February maybe making the move around the rest of the diagram. Now, what does that mean? That means that if the MJO helps to dominate the pattern, the ridge that's over the west coast will move. It'll move in this direction, and that'll take the flow and allow it to do something a bit more like that. Now, you know what this means. If there's a trough to your west, the flow and the cold air comes like this, and it ejects right in through here. And that's why the long-range models for the month of February have from the Mid-South through almost the entirety of the East Coast with above average precipitation. It's going to be an active February based upon that high pattern. In terms of temperatures, take a look. I don't think there's any surprise here. We're going to see more days with below normal temperatures than above normal temperatures. I'm very concerned, by the way, if you're thinking about cotton and what's going on in the southern plains. This is an area that's going to see more warm days. It's going to see days with drier conditions. That's going to deepen the drought that's in the southern plains. I'm watching that very carefully. And since we're talking about drought, let's finish this up with a quick look at South America, because we know that over the last 2 months, southern Brazil and Argentina, which is not colored here, have been very, very dry. Now, right now, we're watching a slow-moving front that's coming through Argentina, and it is producing a lot of rain. And over the next week, this is hitting some important areas in Argentina, like Cordoba to Santa Fe to Buenos Aires and Uruguay, while it's going over drier in northern Brazil. Now, the significance of the drier signal in northern Brazil is this is going to lead to very rapid harvesting of soybeans and then planting of the safrinha crop of cotton and corn. And then as we play this forward, this is a 1 week sliding window, taking you out fully into week 2, which is there. We still favor drier north, but wetter down here in parts of Argentina. Now, what is the implications of this? The first crop planted in Argentina already had too much damage and destruction to it due to the drought and heat, where they saw temperatures easily getting to the triple digits here throughout January. The later planted crop is going to fare better because of this precipitation. But those crop conditions reports went from 70% good to excellent on corn back in December down to like 23% in the month of January. So that crop is negatively affected, but we're going to watch to see what this rain does to either halt the degradation or to maybe give us some improvement in the crop here in Argentina. So lots to cover today, and I appreciate the little bit extra time doing this, but we had a lot just to think about and see here. I'll keep my eye on all of this, and I will report back to you again to keep you posted, okay? Appreciate your attention. Thank you.